Well, are you ready to hear from Chris White? I know I am. I had a ball talking to him at HomebrewCon. I had a ball talking to a lot of you at HomebrewCon and Craft Brewers Conference. That was great to see everybody, but it was especially fun to spend over an hour with Chris, and we were kind of prepping for this event. Well, listen, you're going to today hear his best tips and tricks for repitching and washing yeast. I polled everybody, and that seemed to be the most pressing topic that you were most interested in. I will have to say there's not a lot of good information out there, so I'm really looking forward to hearing what Chris has to say. Who am I? I'm Doug Piper, and I'm the host of the Gourmet Brewing Channel, and I'm in Greenville, South Carolina. And I want to thank you so much for taking the time to join us, because today we strive to make your day more delicious, one sip at a time. Now, please share in the chat if the audio and the video is okay. I'm very dependent. I can't see that. And while I'm looking, let's see. Looks like Pickerington, if I pronounce that right, British Columbia, Eric, Princeton, New Jersey, looks like that's Dennis, Central Mexico, Russell. Oh, Russell, how are you? A lot of names and faces there that I recognize. Joshua, how are you? So I see a thumbs up from Joshua. I assume that means the audio and the video are okay. Let me know if you find out, or so you find it's changed and it's not there. And I appreciate everybody putting in there where you're viewing it from. That really helps us understand our audience, and just it's fun to kind of see where everybody's from. Let's see. There we go. Audio and video are okay. Hello from Seattle. Looks and sounds good. Awesome. All right. Well, also vote in the polls. As you know, I want this channel to be all about the topics and questions that you have. And I use these polls, and I use polls in YouTube. So there's a link there to my YouTube channel. I'll try and post it in a minute again, but I'm really starting to use that YouTube channel in the community chat. It seems to be a lot better than Facebook. So check that out too. So let's bring on Chris. And Chris, we're not going to bug you too much yet, but we do want to see that you're actually here. And if I can click the right button, there we go. We appreciate you being here. It's a really big deal to have you. And I want you guys to know, because I want you to know a little bit about our star speaker today, Dr. Chris White. I really think he's a legend in the brewing world, and he's the big brains behind White Labs, a game-changing yeast company he started back in '95. He's got some serious credentials with a PhD in biochemistry. He worked at Genentech, the first ever biotech firm. He's written a great book on beer fermentation and even designed a craft beer game. And Dr. White has also talked at UC San Diego, and he has an award from the American Homebrewers Association. Now, Chris, we're going to come back and get you in just a minute. There's a couple of logistical things I want to go over, so see you in just a quick minute. All right. Well, if you're a first-time viewer, we have monthly fee events with folks like Chris. We had Stan Hieronymus before that. And coming up, we've got Lars Garsol. And this is our 93rd free major event, thanks to the Patreon supporters that are on the channel today and then catching the replays. And there's individual contributors. A lot of you notice the login gives you the option of you can watch it for free, but if you want to buy me a beer, that's always appreciated. There are expenses with this, and it's great to get those covered. Gourmet Brewing is a community-funded channel, and it's supported by your generosity. And so many of you that are watching today, and so many of you that I'd met at CBC and HomebrewCon. So Patreon is also one of the best places to support that, and you can learn more with that, clicking that green button down there. Don't worry, if you click on it, you're not going to sign up. You have to take it several steps further. So you can just check that out more. And supporters on Patreon get the audio files, behind the scenes, brewery tours. We had some full-length interviews with Ken Grossman, John Mallett. So consider joining the Patreon. It's a big deal. And coming up, I'm going to spend the afternoon with Charlie Bamsforth at Sierra Nevada and San Diego, Mills River. And looking forward to that. And I want to see what questions that you have for Charlie Bamsforth. Now, let's get on with this. Please click the follow button in the upper right-hand corner because that notifies you when I go live in case the emails don't go through. If you have any technical problems, refreshing the browser solves most of those. Reduce resolution with the little gear symbol in the right corner. And submit your questions. We've already got 11 questions there, Chris, so it looks like you're going to have a busy second half. Please answer the polls. As I mentioned, that's huge. And when you register, thank you for checking auto registration. And that way you can get automatically registered and you don't even have to go through the hassle of registering. Also, contact me if you need a virtual speaker or do private tastings or even events. And as I mentioned, August 10th, we're going to be working or having Lars live. He's going to be talking about Vike yeast. And don't forget, my favorite part is the Zoom after party. I'll put that link in a little bit later because it doesn't start until it's all over. But we will all jump in there, and Chris might even join us there in the after party, but I'll definitely be there. So, Chris, I'm ready to stop talking and get you on screen. There we go. So, I've been working on a question for you, buddy. I want to know, you can buy all these nice packets of yeast, whether it be from White Labs, Fermentus, there's a bunch of great places. And so it seems like, there's no contamination risk, there's no dead yeast, and they should have the right number of cells. But if I repitch yeast, I think I'm worried about contaminants and dead yeast cells and insufficient cells. It just starts all kind of question marks. So why do it?
For the same reason you make your own beer, then buy your own beer, I'd say. You can. It's what brewers have done for a long time, hundreds of years, repitching yeast at least. And you have all the tools, and especially in a commercial brewing to do it. In home brewing, it's just figuring out your own process a little bit, talking about it like this. And I think as soon as people do it, they realize, hey, this is pretty easy and it's pretty good.
So if it's that easy, what are the major pitfalls that you need to be aware of before you jump into this? It seems like you need a lab and all kind of crazy stuff.
Great question. Again, happy to be here today and follow up what we talked about at HomebrewCon in San Diego. That is an interesting question because I scratched my head on that one a little bit when I started traveling outside the United States and met people who weren't repitching as much as the commercial brewers were trained in the U.S. to do at the time. And people would say, I can't repitch yeast because I don't have a lab. I'd heard that more and more. And what didn't make sense to me is most people that repitch yeast don't have a lab. And second of all, you could say that about making beer. I can't be a small brewery or home brewer because I don't have a lab. I'd always recommend a lab. I mean, that's what I love doing. I like microbiology. I like chemistry. I like doing testing. But that's not most people. And it also makes your beer, have chances of being better, of understanding what's really going on in the beer. Having a microscope to look at yeast is great, but you don't necessarily need a lab for that. That can go on the bench right here, And so that is more of a reason not to do it than a reason not to do it. Saying you don't have a lab is sort of a reason not to do it versus the lab, not having a lab requires you not to do it, if that makes any sense. Like I said, it's just, it's similar to the first answer. It's the same thing about making beer. You love making beer. You love doing all the bits and pieces for it as much as you can do your own. And this is one of those things that I say is easy. I've been doing it for a long time, but anybody that I've seen, train, I can't think of any really failures once, people say, oh, it doesn't work. If that's the case, your beer's not good. If your beer's not good, you really can't collect yeast. That's true.
Well, you tell it like it is. Well, let's jump into the equipment then. If you don't need a lab, what do you really need to do this right? I think most home brewers don't mind investing in tools, but they like to buy the right ones, and there's a lot of junk out there. So what would you suggest for, a bare minimum or a good place to start?
Well, I guess starting at the kind of beginning of years ago, people fermenting in 5-gallon carboys and 20-liter-ish batches. You get the beer cold, you drop the yeast out, and then you have to remove the wort, the beer now on top of the yeast. You got a little bit of yeast, you got a lot of beer, and now there's new fermenters and things like that. But this kind of thing still applies. So in those carboys, the hard part was to get the wort, the beer off the yeast. You have to siphon it off. So this is where it gets a little bit of aseptic techniques. I would autoclave a racking arm, and stainless steel one, and have silicone tubing and siphon it off. But anyway, you want to, you're not pouring it off. Pouring anything with beer, it's going to oxidize it. With fresh wort, it's going to get it contaminated. There should be no pouring around brewing or home brewing. It's really using tubing and peristaltic pumps or just gravity. So you remove the beer, and now you've got a yeast cream. Back in those days, you mix it up, collect your liter or so of yeast, and put it in the refrigerator, burp it a little bit because there could be some CO2 from it, and try to use within 2 weeks. That's, as simple as it can be. The beer has to be good. The yeast health, so much stuff we're going to talk about today is actually what happens in the beer, not the collection. If the yeast health is made good at the beginning of the last batch, from your storage, your pitching, your finishing gravities, your collection time, then the collection itself is pretty straightforward. Now with larger fermenters and ports and valves at the bottom, collecting the yeast at the bottom is quite a bit easier. You open the valve, right? And that's what's done in commercial brewing. Yeast is at the bottom. That's why fermenters have a cone. If people aren't collecting yeast, but they have a cone in the fermenter, why'd you get a cone? It's more expensive. The cone's only there for yeast collection. And now we have more and more homebrew style fermenters with that kind of setup and something to collect it into. I'll stop there for a second. Yeah.
So if you were to kind of summarize the equipment that's needed, can you 1, 2, 3 it?
Yeah. Well, say on the commercial side, it's your tubing. Sometimes people use a special hose, tubing on the home side maybe for yeast collection. That's pretty rare, but some people do. I mean, the more anal you get about it, the better. There's nothing wrong with getting as really, really careful as you can. The tubing or hose to collect into, having a dedicated vessel to collect into. Yeast brink is the traditional name. A propagator is where you grow yeast. A yeast brink is where you hold yeast. That can be a liter Pyrex jar. It could be a 20-liter carboy. It can be real traditional yeast brinks. We make one with our film called a flex brink. It's 30 liters for people to collect yeast into from larger fermenters or really small commercial fermenters. And then, the add-on things, having a microscope is great. Plating your yeast on selected media is great. It's what we would do. It's just rarely done. But, I would put that in the same category as that's good to do to your beer. Test your beer. Have fun with that. Test your yeast.
So you mentioned storage of try to use that yeast within 2 weeks. Is that kind of the maximum that you can leave it in the fridge?
Well, it's not the maximum. It's just best practice. I mean, yeast is not something that just lives in our beer. It lives in the wild. It lives in nature. It survives more than 2 weeks, right? We're just sort of talking about best practice to get the best healthy yeast you can to put it back into the beer. And so I was sort of taking that as a challenge and tried to make our yeast higher viability. And 20 years later, we're still working on it, but we've got yeast that can be in the 80 percentile of viability in 7 months. But when you're making a beer, usually it's about 50% viable after 30 days. And so if it's half dead in 30 days from a beer fermentation, there's a lot of different reasons why, but it's 2 weeks is a timeline that's more than 2 days. That's kind of is more reasonable. That still has a really high degree of success. Unless it's not perfect, because that 2 weeks, it's not like every time you collect yeast, it's 100%, right? That's what we're started with when we make it. But depending on when you collect it, I mean, what if you collect yeast that's at 50%? So we'll talk about the collection times, or 75%. So this 2 week recommendation is yeast that you're collecting that's really healthy, which is not, hard to do, but it's maybe just learning it is a little bit difficult.
Best practices is what we're coming back to.
Yeah, best practices.
All right. Well, we've got a beer to open, and I've got a Coors Banquet. We talked about that. That's not really a yeast-forward beer, but it's kind of an interesting yeast, isn't it?
Yes, the Coors yeast.
Yes.
Yeah, it's a really interesting strain. It's an old strain, right? So most of us are working with newer versions of strains. If you look at the genetics, we did a full genome sequencing of 157 yeast strains a number of years ago, and there's been a whole bunch more done since. And you can really see the variety of full genome of different yeast strains and see the evolution as brewing has happened through genetic changes. And, you got Anheuser-Busch and Miller Brewing Company and Coors, in the United States, really were very adamant about using their old strains, whether they were from 18 something, or a number of years after that. There's no way to really know, but they're really trying to use authentic old lager strains that they would, brewers would sit around at some of the master brewers meeting when I was just young and they were older, and they would talk about the Anheuser-Busch yeast, its apple characters, and the Coors yeast, the banana characters, and the Miller yeast being very clean. And, they just talk like any other brewers. They weren't marketing people. They were brewers talking, and they talked about their different yeast strains, much as we would.
Well, I'm going to try and get a good pour out of this. Ooh, I don't think that head's going to last long.
Yeah, you got the nice bottle.
Well, it looks better in pictures. Let's see. I'm going to get in. Let's see. Let's get into this camera. Nope. Here we go. Yeah, I think that head's going to disappear in a hurry. All right, so what characteristics, yeast characteristics, are we going to get off of this very neutral beer?
It's neutral, but there's a lot of yeast work that's gone into that beer. A lot of care, a lot of repitching, a lot of yeast health. There was a presentation by some Coors brewers a number of years ago, I guess a long time ago now, that I remember really talking about, hey, the best way to make your beer taste the best and consistent is focus on yeast health. Make your yeast really happy. And that just never ends. That conversation never ends. That's what we're going to talk about today. I think some people think, okay, maybe the larger brewers, they're really cutting costs. They're using dry yeast back when that was bad and stuff like that. That's just not the case. They spent a lot of time on very interesting cultures and very best practices to make their yeast have certain properties, because while that's a very light beer, without the esters from that yeast, it would taste like nothing, right? I mean, really getting so these lighter American lagers and lighter lagers around the world really require pretty important yeast characteristics from these little esters and things produced to make their beer taste like beer besides cardboard malt.
So are you saying it could be more neutral than what it is?
Absolutely.
Oh, really?
The Coors yeast is pretty wow. It's you're getting some of that banana, you get some of that phenol. The only reason you're not tasting more of it is the beer's been diluted on purpose, brewed to higher gravity, and diluted as part of their process. Frankly, I'm a little surprised more craft brewers don't do some of that, with the fermentation capacity being a thing. But apparently adding water later is upsetting to some people. But we add water in all sorts of our processes, and it's not to make a watered down beer. It's just bring it at higher gravity to take it down to the gravity that you need to, or the alcohol strength that you want. But not a lot of small brewers have access to deaerated water and all those things either. But I think just the
so if you're
sounds so.
Is there any chance that you could get a little bit of that yeast out of the bottom of a bottle, or is it so centrifuged that there isn't a cell left? Ain't gonna happen.
Well, Coors is not pasteurized, so there is always a chance. They're really proud that it's not pasteurized, but they do a lot of filtering work. I've never got any yeast out of it. I have had full strength Coors in Golden, Colorado. Full strength. I mean, you could call this full strength. You know what I mean? Like the high gravity beer.
You're saying as it's brewed or fermented before they add the water.
Right. So if you want to maximize your facility, you carry that fermentation all the way out at high gravity. And that was always called high gravity brewing, not watering down. They used high gravity brewing as the terminology, but it turns out a lot of home brewers and craft brewers, I mean, we're all in that high gravity area anyway. And that's the kind of strength that we consume our beers at. But their high gravity brewing, it started out at like 16 Plato, 17 Plato, 18 Plato, but I think most of it settles around 18 Plato now. And it's interesting to try. What people noticed was the esters were higher when they started doing that. So that's why people started pitching more cells per Plato, because people didn't used to ferment much over 12 Plato or 13 Plato. But when they started doing high gravity, that's kind of where the scale of adding more yeast per Plato came around. Because you add more yeast, you lower the yeast growth, and you get the same esters that you would at the lower gravity fermentation.
Well, I have to admit, I did not think we would have a fascinating discussion on Coors yeast.
Yeah, I mean, if you have a Coors Light sometime and have it sit now a little warm, you'll taste some of that banana and phenols in there. It's thought of as really clean and really neutral, but it's a pretty old lager yeast. Like we have a yeast strain that we have in our bank, and it gets produced sometimes under the vault. And we had it at Craft Brewers Conference, made with a beer. It's Zurich lager yeast, and it's an old lager strain. And people thought, this is not a lager; it tastes more like an ale or Belgian or something. No, the old lager strains just taste that way. They have a little more umph to them, a little more less cleanliness, a little more of that Saccharomyces eubayanus DNA. So instead of Saccharomyces cerevisiae DNA, and we've moved more lager yeast more and more towards more cerevisiae DNA, ale yeast DNA, and so they've gotten cleaner. But some of the the big breweries that I mentioned, they still have those old strains, and so dilution really cleans them up.
Well, let's talk about best practices as far as the workflow for yeast harvesting. I mean, it sounds like we're not going to get anything out of the bottom of this bottle, but where would we start if you were a home brewer or a pro brewer and you wanted to establish, a great workflow and a great workflow process?
Reading some of your things. The flow process for which part again? Sorry.
For harvesting or repitching yeast. So you would be harvesting it and I guess washing it. And could you take us through all the steps that you think are essential?
So yeah, harvesting it when the beer is done fermentation is important. I mean, it doesn't just stay at the high viability, right? You've just made a beer. The glycogen was built up during the starvation phase, so the yeast have something to kind of consume later. So the longer it sits under the beer, the more that glycogen goes away, the more the compactness of the cone gets larger and larger. If you're in a 20-liter fermenter, it doesn't happen too badly, but once you're, say, 20-barrel fermenters and above, it starts to make a difference in 12 hours, in terms of when 5 hours when the yeast is collected. So, a day after terminal gravity, you want to collect the yeast. People used to collect the yeast early. That was in all of Charlie Papazian's books back in the day, just sort of his practice. And that's not really necessary or even desired. You want the beer to finish fermentation, collect the yeast, and store it cold. You're trying to keep the yeast in a state of hibernation. It's alive. It wants to get into another beer. It wants to make energy, right? So if you do anything that stimulates the yeast, it doesn't have to be carbohydrate, sugar, to want to do something. It'll lose some of it'll try to grow when there's nowhere to grow. So you want to keep it cold. You want to keep it out of the presence of oxygen, which is hard. I mean, when you're transferring things, that's why you got to be really careful about how you transfer. So you want to keep oxygen pickup as negligible as possible. The oxygen is not damaging to yeast cells. In fact, they love it, but they will try to do something with it, which is metabolism. And you're trying to keep them from doing any metabolism. So cold and dormant and without oxygen. Washing's not a big deal to me. I mean, it's not really done that much commercially. You collect the yeast in brinks, you keep it cold, and then you use it again. And you use it, doesn't really matter the temperature as much either. Attempering it to your pitching temperature is great. I mean, it's a good practice, but it's hard to do that commercially in big yeast brinks. So, but you can wash it, if it's a high gravity beer, so you're concerned that you want to store it for a while, there's alcohol there, but you're also washing off a lot of the nutrients that were in your malted barley wort setup. Wort is such a great media for yeast, far better than, grape juice, wine or seltzers or ciders. Malted barley is fantastic for yeast. So we don't really like removing it from that.
So the term acid washing, is that relevant nowadays?
Well, you can imagine when everything used to be open fermenters, there's a lot of terminology that came from the open fermenter days. Say somebody gave you some lager yeast that some people were using in Bavaria, and you were looking for your yeast on top, and it was all gone. You started calling it bottom fermenting yeast, even though it was there for a while. It just didn't stay up there as long. So other things like at that time, same time period, acid washing became important because we realized people before us realized that if you held the yeast at a pH close to 2 for about an hour, it would reduce the population of lactic acid bacteria, which just was always a part of yeast cultures until modern times and aseptic work and the ability to remove it. It wouldn't kill it, but it would reduce the amount. So people would acid wash, and all the big breweries did it. Some still do because it's just part of the practices. But it's something that's not necessary anymore with aseptic techniques and good brewing practices, and your beer is clean and has a decent shelf life. Acid washing is not as necessary anymore. And what's good about that? It's one more handling of the yeast. It's one more place to introduce oxygen, which if it's right before fermentation, that's not a big deal. But if it's a washing that then you're going to be holding the yeast for a while after that, you're doing more harm than good.
So when you put it in your container to put it in the fridge and you've used tubing to put it in there, so you've minimized the oxygen pickup, should you leave an air gap between the top, or like you do beer, should you cap on foam or try and minimize the air in the jar? You're setting yourself up for an exploding jar.
Yeah, that's not too as important because the absorption of oxygen in beer is damaging because the proteins in beer get oxidized. Yeast itself getting oxidized is actually something that's still being studied, but it's not that clear that causes much damage. But a cell can get damaged by oxygen too. But the main thing is, it's just part of their metabolism, part of our metabolism, right? We breathe oxygen. Yeast consume oxygen as well. They're not anaerobic. They can't survive in a non-oxygen environment. They only do that because on the positive side of oxygen, we give them the oxygen in the beginning of fermentation. And that's a whole nother thing. So yeah, they want it. The more, the better at that point in some ways for the yeast. But just like when you're collecting it, collecting beer, people think about keeping oxygen away from beer, and it just keep that in mind for yeast too. Purge a tank if you can. So you have a yeast break, you want to purge that with CO2 first, and just think about translating that to all the way down the line to smaller and smaller vessels, how you would keep the oxygen out of it.
Okay, so bottom line, if you were to put it in a quart jar or a pint jar, do you bring the water all the way up to the top or leave a half inch of air?
You really can't, yeah, because you got to homogenize the yeast later, and that's some of the most difficult part of yeast collection and reusing is getting it homogeneous, unless you're using the whole thing, which sometimes you do. So you got to kind of get it back into solution, and so having some headspace is important. It has a lot of gas in solution usually because beer has gas in solution, even if it hasn't been carbonated yet, because CO2 is still in there, especially in the old 20-gallon kind of ferment carboys that most people used to use, and I'm sure some people still do. It gets a little supersaturated with CO2, which is not great for fermentation anyway, but it's also something that is going to be there when you have the yeast, and the yeast might also make a little more CO2. It's still alive. We've been packaging yeast for 28 years too, so we know the challenges associated with packaging yeast. It doesn't matter if it's in a rigid container. The gas is there. The gas is there. When we went to film, it's even more important to you can't have. Film would just expand like crazy. So having yeast that is not going to produce CO2 is really important.
So as we kind of look at repitching and summarize the workflow best practices, I want to open up a beer that I think is a bit yeast forward, quite a bit yeast forward. And I think we both got a Weihenstephaner Hefeweizen. That's quite a bit different than our Coors Banquet. And let's talk about that a little bit as we wrap up kind of the best practices that go along with the pitching. And I will set up here and see if we can get this going. All right. Now we have a video on this, which I will start, and then I think I will pour mine. Move that out of the way. So I'm going to switch to that right quick, and this was sent to me from Vine Stefaner. So let's check this guy out.
Translates roughly to wheat beer in English, this style is a favorite among Bavarian natives. It's a thirst-quenching and refreshing ale that's hazy, fruity, and effervescent. Weinstephaner Hefeweißbier is the benchmark of the Hefe style, not because we are biased, but because it's the #1 selling imported wheat beer and highest rated in the USA market. Coming in at 5.4% ABV, it's a full-bodied golden yellow wheat beer. You get aromas of cloves, and when you take a sip, it finishes clean with a refreshing banana flavor that makes you want to take another. Brewed with 60% wheat malt, barley malt, and hops from the local Hallertau region, the world's biggest hop growing area that sits just north of our brewery. Our iconic wheat beer yeast strain, used in the recipe, gives the beer its fruity smell and balance in between banana cloves and a hint of citrus. Best served in a wheat beer glass with a great head to make sure you're getting all the aromas that the brewer intended. The skinny opening in the top of the glass keeps the head of the beer intact so you can breathe it all in. Available in cans, bottles and draft, we hope you enjoy our Hefeweißbier. Prost!
All right. Chris, the pressure's on. I got to see if I can pour one like Anton did. How did yours turn out?
It's sitting here a little bit. It's got a good foam, you know.
Okay.
Came down. I had it. It was to the top there, and it's we rinsed this glass, but yeah.
I recognize that glass. That's from the tap room, isn't it?
Yeah, right downstairs.
All right, I'm going to give my pour, and maybe you can talk about it a little bit.
Well, it's no one can top that description, but it is a great place to drink Weinstephan. If anybody's been there, got the university there and brewery there, so everything's fantastic about it. Airport's there, and students kind of do a lot of different things there, right? So they kind of run the yeast bank, and that's why it kind of changes over time. I mean, the people that are involved in it, now there's different versions of it. And so sometimes in beer, we're thinking of Weinstephan as the yeast bank because that's the university, the agricultural university there north of Munich. But there's also this brewery on site, full restaurant, all the Bavarian food you could want, and a bunch of their beers. And I mean, it's just such a great, refreshing beer. Weiss beer like this and vice versa. Their white sausage, great Sunday morning Bavarian combination. And so when I think of Weissen, I think of with sausage, with a white sausage. So maybe with my leftovers, that's what I'll have tonight. I'm gonna barbecue some sausages. See, beer and food just go together. And such a yeast forward beer, this beer would be completely different without that yeast, right? And it's interesting that the Germans went for such a flavor forward yeast whenever this came about, because everybody used to make ales, right? So this is something that stuck around. And even though maybe Belgian style beers got made fun of in that part of the world for their kind of characteristics, not by homebrewers, you know, we love it. But then there was this beer. What's okay about this beer being so yeast forward, banana and clove, because it's delicious. That's why, it's very easy. It's not very heavy beer. The wheat malt, the malt bill's light. I think lower calorie, easier drinking beers are never go away. It is why there's a new lager revolution. All the young people are trying to drink lower calorie things, and this was an early beer for a lot of people. Yeast wise, it's kind of funny. I went to a different German brewery, Paul Hunter, one time, their old brewery, and we were talking about their yeast collection. Their yeast brink tanks were outdoors. That's how big they were. So, to collect lager yeast and reuse lager yeast, because they made a lot of Helles and things there. When I said, where's the tanks to hold the wheat beer yeast? They just kind of laughed. You don't need much yeast for wheat beer. So, that we just got a little tank inside. That just shows the big difference between the yeast handling on lagers and the resources necessary to hold as much yeast as you need versus a wheat beer where you're pitching less yeast, the temperatures are higher, so it's going to go faster. You want expression of flavors for another reason not to have a high pitching rate. And you can really dial that in with the banana clove characteristics, say, of our yeast, WLP 300 hectobiotic yeast. If you go a little higher in temperature, you're going to get a little more banana. You go a little lower in temperature, you can suppress that ester, that banana ester, and have it taste more like this beer, which is a little lower. The Bavarians tend to like it a little lower banana. The Americans tend to like it a little higher banana, but everybody has a different viewpoint on that.
Well, I've looked at that long enough. That is one nice summertime beer, especially. So, what if I wanted to harvest this yeast? There ought to be plenty of that in that bottle, wouldn't there?
Not really. The Germans pasteurize it.
Okay, so it's all dead.
Yeah, because the feeling is the pasteurization also breaks out more protein, so it gives you a permanent haze. That's how they're kind of taught at Weinsteffen. So pasteurization is not only for the stability, it's for this haze development. It's another hot break of protein. And in fact, it got to so much at one point, the Bavarian courts at Munich that still oversee Reinheitsgebot, the Puritan law, had to they were always still adding things and taking things out. It was something that was set up a long time ago, but it's still administered through today to keep it alive, this purity law. But they said, okay, guys, it has to have 1 million cells per mil in it to be a Hefeweizen, So that was added kind of as a regulatory thing or as a guideline for making sure that this beer still had yeast in it. It doesn't have to be alive, but, unless things have changed in the last few years, that was what it was, that you had to have 1 million cells per mil. So I'm sure there's wheat beers you can get yeast out of. Just a lot of them, the yeast are dead. Yeah. They don't necessarily blow up, right? That's why we stain yeast under a microscope. Dead ones can stain a certain color because they can't oxidize the dye. And methylene blue is the usual one. So the dead ones have this dye that doesn't get reduced, and so it has the color still. But it's intact. You already know it's dead just under the microscope if you didn't stain it.
So I was asking Jason Perkins about his Allagash white beer. And I said, tell me about the yeast and what a homebrewer needs to do to get it. And he said, well, go get you a can and get some yeast out of it and go for it. So if I was going to do that, what would be the short process for that?
Yeah, I mean, collecting yeast from beers is a lot of fun. As you mentioned, asking me earlier about the brewery collecting the yeast, let me just say before I forget that the best way to collect Hefeweizen yeast from your fermenter is the top of the fermenter. Because Hefeweizen yeast really like the top, and it's really hard to get it to go to the bottom. So if you can collect it from the top, that's great. That's how all yeast used to be collected, whether they were in Germany or anywhere in Europe. everything was open, right? You collect from the top. So even lager beers. But this is still a beer that would be really good to collect from the top. Also, I know that's not very possible for most people. So why that was early on, like this was the first specialty beer a lot of craft brewers made and homebrewers. Doesn't sound too specialty today. I mean, there's a lot of new offshoots of things, but we would get calls and say, okay, how do I collect the Hefeweizen yeast? How do I collect it? I mean, people would ask for Anheuser-Busch if they were making one too. Like nobody has all of these answers. The yeast are complex and they're alive, and you know how to collect them, how long to keep them. All these are classic, never-ending quests to get better at handling yeast. So people said, you know what? I'm going to use a new yeast every time. I'm not going to collect the Hefeweizen yeast and repitch it because it's too difficult. So yeast forward beers will taste different. And why that's important is I still hear that every new style that comes along. But no one says that about Hefeweizen anymore. They just figured it out how to collect it because it's too good a yeast sitting there. You know, it's going to make a great beer. So people figured it out, and they have done that with every beer style. So when I hear it today, like some new thing comes along, says, "Oh, you know what? I better not use liquid yeast on that one because I can't harvest." Or I better, you know, whatever it is. There is no way. There is nothing out there that exists. No fermenter, no beer type that you can't collect yeast from. Brewers figure it out. We don't figure it out. I'd say brewers figure it out. So now to answer your question about if you want to grab a can of beer or a bottle of beer. Again, get it cold, pour the beer out. You have a little layer of yeast at the bottom. It's kind of similar to what I talked about collecting from a carboy, a 20-liter carboy. Get the yeast into hopefully a little sterile test tube or something. I would plate it out on a petri dish because there's lots of different things in a bottle of beer. There's non-brewer's yeast. That's not going to taste very good. There's expecting that to be pure is not going to work very often. If you didn't want to plate it, you could just simply make a little beer, you know, make a little test batch, taste it, see how it tastes. But if you can plate it out and collect some cells and then do some selection there and then grow it up and make a beer, that would be the way to collect the yeast from a beer.
Well, that doesn't sound too bad. Should I make a homemade centrifuge and put it on a rope and spin it around and see if I can force some to the bottom?
Sure. You want to get to 5,000 RPMs or so, you could do that.
I don't think so. All right. Well, that's good, Chris. Well, thank you for that. So one of the things that we talked about, and you really kind of threw the challenge out there when we were talking at HomebrewCon, he said, you know, all of us can brew good beer. That's not that hard. But as we put all this together, and you said, but really we want to brew great beer. And I love that. We do want to brew great beer. So are we going the wrong way if we're trying to repitch and work out all these complications? Or is what would you recommend to brew great beer, ideally with repitching?
Well, I think some of the best beer does come from repitched yeast. You know, you're adapting yeast to your beers, your brewery. Commercially, it's a lot easier because there's a lot of beer being made. It's always more difficult from home brewing because you're probably not making beer every day. You might not be making the same style, so you might be collecting several different yeast strains. I understand there's more complications on the home brewer side, but on the commercial side, I mean, there's just no reason not to. No matter what type of yeast you use, because it's part of our training as brewers. It's part of our we're trying to make the best thing possible. We're trying to make the most flavors possible. We don't want to be like distilling or baking or these other industries that lost the importance of yeast. I'm being very general there. That's not everybody, but in those other industries, there's very few different strains to use. That could happen in beer too. because we want to make it easier on ourselves. But beer would lose characteristics that no one would remember after a generation or two. Like, talk to a baker about yeast. It's going to be, not everybody, but it's going to be very hard to get to flavor. It's all about performance, fermentation speed, what temperature you at, you try to rise a dough in 45 minutes and get any flavor out of it, it's zero. But that's what most people do, 45 minutes to an hour. Why not 3 days? That's where flavor comes, strains and time. And that the only thing people will say is, well, you mean sourdough? No, I just mean different yeast. But that's what happened. Like, imagine if beer, we said, I want to use this different yeast strain. And somebody said, oh, you mean sour beer? If that was the only thing left that had a differentiation of strain. And I think it's really cool that beer hasn't had that happen to it. Because we get to buy these commercially and enjoy really delicious beers. And so I think as an industry, I don't know, we have a little responsibility to keep that going. This stuff was handed down to us for a certain reason, well before it was understood why. So, I think you always got to be a little red flag, a little skeptical about convenience. And it comes back to training and good practices, because there's a consequence on flavors. You want to collect yeast, keep it alive, add it back so it blooms in the next beer and makes a beautiful array of flavor and aroma compounds. You could do that without repitching, but it's not necessarily any more consistent or any better or any different. You're probably going to limit yourself to how many different strains you use and things. So, because basically, if you're comfortable with repitching yeast, whether you're smallest home brewer or the biggest commercial brewer, you could have a whole bunch of different yeasts going in your brewery, and just make the best beers you could possibly make.
I drove. Well, for those of you who have heard this story, Scott Jennings, the brewmaster at Sierra Nevada in Mills River, North Carolina, invited me to spend the afternoon. And so he took us all through the back part, spent a lot of time in the lab. And every time we looked at something, I would ask him what yeast that they were using. So about the 6th or 7th beer style that we went through, he looked at me and he said, Doug, do you not understand? We use the Chico yeast in just about everything except the lagers. and I was floored. And he said, you've got to treat that yeast like a good friend. He said, you got to get to know it. You got to understand it has its moods. He said, we don't want a whole bunch of different yeasts. We like the Chico yeast.
Yeah, they do so many things. All right, sometimes I feel like I'm using them way too many times in examples. But they do a lot of old homebrewing practices, transferring the beer to another fermenter before it's done. And they like the results from really getting a highly attenuated beer because it kind of, as I was told Sarah about one time, it tumbles the beer on itself. And then any oxygen pickup in that transfer, there's still yeast doing something as it's finishing out the beer and absorbing that oxygen. And I don't know, but too many breweries that still have enough tank capacity to transfer a beer before it's done, and then to another serving tank, a conditioning tank. And I don't know, they had lab work from the beginning. They stay on trends. Unfortunately, Anchor Steam is closed here in San Francisco, closing, and California is losing another brewery. And it's a shame. I just don't know anybody who had been drinking that beer for a long time. So, and I guess people just didn't drink it. But you can't say that about Sierra Nevada. They've just strived for whatever reason. No one knows the exact formulas here, right? Otherwise, we'd all do it. But to make great beer, and they've had lots of different brewers coming through there. And they've done it. They've created different styles, but they've managed to use that same yeast strain for most of them. Other breweries have tried that. Stone Brewery in San Diego, they started with one yeast strain, and for years always said they would never use another yeast strain. Now, of course, they're making lagers too, but when you made, if you're trying to make the whole craft portfolio, the Belgian style beers, the different British style beers, you can use one strain. Nothing wrong with it. That's a lot of your flavor. So the different strains add to some of the authenticity and characteristics of different beer styles.
Well, it was fascinating, and it was humbling to realize they didn't have to play with all those different yeasts. Well, we have one more beer to open up, and this is a very yeast-forward beer, and I have a short video. I was fortunate enough to spend the day with Olivia Didica at Saison DuPont, and this is a short video for when he was taking us through a tasting. So as we get ready to open that, how about checking out this video? It was a really unique experience. And this was right at the end of COVID, if you notice the masks.
So it's why we prefer to use a Willy Becher glass, because we think it's the closest to the original glass. We have quite a lot of phenolic notes coming from the yeast and malt, but also some citrus notes. But phenolic is really present. Fruity notes also, not only citrus but also white fruit. But most typical for me is the phenolic, and also the bitterness. Again, phenolic on the taste. Quite dry, but still some sugar in this one because it's not an old beer. It's a beer from September, so we have just 7 weeks.
It was a great experience, and it was fun as I edited that down to relive it. So I'm going to pour mine, and Chris, maybe you can talk about the yeast characteristics of a Saison DuPont while I'm doing that.
Yeah, Saisons were the rage of home brewing and craft brewing for a period of time. And actually, when kind of hazy, we started calling East Coast, IPAs, things like that, to what they're called today. But at that same time is when I really thought or saw Saisons go down in popularity. People buying less Saison yeast, people buying less Saisons. That kind of hazy thing went over to the other thing, and it's so I don't get as many opportunities to have a Saison or talk about Saison DuPont, but it's similar to what's happening now. We've got London Fog, and we got the next strain to do things with on the hazy side in different ways. When Saisons came out, Saison DuPont yeast was kind of our first Saison yeast, and then there was another Saison yeast, another Saison yeast, another Saison yeast, because people they started getting a little bored. You want to try a different strain. You want to do a different blend. So that was a fun run, and it's not going anywhere. It's just not as popular as it once was. It's people. This is an example too. Like when something new comes, it's hard sometimes to deal with something that's a little more difficult. It's not California ale yeast. It's not these strains are more unusual. They may or may not like maltodextrin as well. They may or may not like cold temperatures. So Saison DuPont, for example, our Saison yeast really likes to ferment warmer. But you don't have to start it warmer. It's just about letting it warm up during the fermentation. And that's done in Belgium very easily because the fermenters are larger. They're designed for that. Like if you do things in a conical fermenter or a small fermenter, and you do it at high temperatures, it'll get a lot more yeast characteristics than this beer has. And that might be too much for you, too much growth. So by having a different fermenter design allows them to go to a higher temperature, which allows, say, this yeast to ferment out much better than at low temperatures. But it just took a little learning curve. I mean, I can't think we've had anybody. I guess everybody knows that already, because no one calls anymore and says, "Oh, it hasn't attenuated." People just learn their fermentation techniques with it. So,
but they have some really complicated, or I won't say complicated, but you've got to deal with what they call it, DuPont stall, and a shallow fermenter, open actually, and
shallow, a big open. Yeah, let all those aromas come out. Ferment as warm as you want, because they're not going to stay. They're not going to. It's a completely different design.
Well, if you noticed it in the video, he likes them aged. He was saying this one wasn't dry enough because it was only 6 weeks old. And when we talk later, he said Saison DuPonts that were 10, 20, 30 years old. And he said they just keep getting better.
Yeah. That's fantastic. I had a sake recently that was brought to me about 10 years ago from Japan, and it was still open in my office at room temperature. Somebody was here the other day and said, "Can I try that?" And I said, "I'm sure it's probably horrible." It was fine. It didn't taste oxidized at all. And that's not distilled. Sake is fermented and still. And some of these things can be a little really mind-boggling when you're so set in beer ways, And in this case, clean beer, and so not clean beer has a whole different set of properties.
Well, Chris, as we wrap up and get ready to transition to the questions, how would you summarize and encourage or discourage, whatever position you want to take, with not just always buying new packets of yeast, whether they be dry or your wonderful wet yeasts? Tell us about repitching, especially from the angle of a home brewer, but also from the perspective of a commercial brewer. How would you summarize it?
I'd summarize, first of all, the idea of it as a part of what we do, a part of the hobby. There was a brewery San Diego brewery that came to pick up yeast today, and I was chatting with them, just the will call area there, and he had bought some wit yeast and made a nice wit, and just thought, man, what else can I do with it? Sometimes the yeast strain challenges you. So he made a white IPA, one-off thing, and it was fun. And now he was kind of thinking, what else can I do with it? Not every strain is California yeast again, where you're just like, okay, let's make everything Chico style yeast. Let's make a wheat beer. It might not be a Hefeweizen, but it'll be pretty good. I don't know. So it's one of your only 3 ingredients, so you don't have a lot to work with, right? Ingredient wise. But man, look at the variety of beers brewers make. And so repitching is just a really good tool to have. I'm sure a lot of your people listening right now do it. Some of them might be saying, "Oh, that's how I do it. It's I'm not doing it wrong," because that's some of the times you take the class or hear something and you think you must be doing it wrong, and you're actually not. And I'm sure that's what a lot of people are maybe thinking right now. And that's why you get financially, I guess it'd be better for us if people bought yeast every time, but I don't expect you to do that, and you shouldn't. I think it's great to reuse yeast, and it's simply watch. And probably this will be some of the questions on the mechanical side, right? But collect it. So watch that fermentation timeline. Don't let it sit back there and forget about it. Like get the yeast off the beer when it's done. Keep it cold. Keep it out of oxygen. Get it back into a beer. But before all of that, it's about how good the yeast was in your fermentation. So if there's going to be questions on yeast health, anything about yeast health might sound like I'm not talking about yeast reuse, because you want to know the real details of grabbing the yeast, right? But as I try to describe, it's not that complex. That complexity is making your yeast awesome in the fermentation beforehand. But the advantage you get is the best beer possible. So making your yeast the healthiest, happiest possible that you can in that fermentation is going to give you a much better possibility of having a beer to attenuate correctly, taste correct, and on the right timeline. And then bonus, you've got healthy yeast that you can collect. Thanks.
Well, and I thought I would share what these beers look like, all lined up. So, of course, they're labeled. So we got the Saison DuPont, the Hefeweizen here, and we have our Coors Banquet. Boy, it is brilliantly clear compared to the others. Well, Chris, this was a lot of fun, and this was a good choice of, I guess, yeast forward and not so yeast forward beers. I really would love to talk to you sometime about the Anchor yeast, because my understanding is they simply repitch it over and over and over.
Yeah, it was a beautiful brewery. I don't know what's going to happen in that space, but they had set up the open fermenter for Anchor Steam in a positive pressure kind of room, and just reused it. We did some things with them, but for the most part, they really were. This beer was from the late 1800s, and Fritz Maytag had bought it about 1968, I believe. But they were trying to use as many of the old practices as possible.
Well, that's unique. Well, yeah. We're past the top of the hour. We've got 15 questions, so we're going to have to cruise through those pretty quickly. For those of you that have to go, appreciate you being here for the first hour. You can ask a question. You do not have to be here live for it to get answered. And because you've registered, you'll actually get an email with a link that takes you directly to where your question was answered by Chris. So it's a pretty neat system here. So I'd encourage you to put in your questions. So Chris, unless you need a quick break, we'll jump into the questions.
Okay.
All right. Let's go through the first one. Terrence has the most popular question. By the way, everybody has a vote. So that first question is, when you have a slurry which is captured from your previous batch, can you demonstrate some of the methods to quantify cell count per mil of slurry?
Yeah, so it's a really common question, and it's a good question. And there's several ways for me to answer it. Everybody wants a quick formula or something, really, and I'll give you a couple. But I really want to preface it with the only way to really know your cell count in a slurry is to use the microscope. You don't have to use a dye if you don't want to. That's just another complexity. If you're trying to look at live versus dead yeast, you're likely not going to have that many dead anyway. Large breweries sometimes just put it on the microscope and say, is there any blue cells here once they dye it? So, but they've learned to, keep it alive pretty well. So, if you're trying to just count the number of cells, you can do a microscope count. And that's pretty good, except is it mixed well? You're looking at a tiny, tiny, tiny below microliter, quantities. And so you're multiplying that by this whole volume of yeast that you have. However, that's the best we got. Counting yeast on a microscope and having fun with that. Otherwise, if you collect 10 liters of slurry, say in a brewery, from your 10 hectoliter fermenter, and maybe you collect more than that. If you used a liter or hectoliter per 100 liters of beer, generally you have about 10 million cells per mil in the new beer, because most slurries are around 1 billion cells per mil. When you're fermenting your beer, you're in the millions of cells per mil range. In the slurry, it's in the billions of cells per mil range because you're collecting the concentrate, the yeast that's been concentrated just naturally through flocculation. So, we work hard to get our yeast to over 2 billion cells per mil. So we're shipping less water. A lot of liquid yeast is still at 1 billion because that's the easiest way to get it. So it's really hard to evaluate yeast, even if you buy them based on how much yeast is in there, because it's not obvious unless you count yourself. We try to print everything there, whether it's on the sheet sheet or the package. You can find all the information. So, about cell counts and everything. So what I think I'll end that question with, you really need to do a cell count. But if you don't want to, a liter per 100 liters, and you can just divide that by whatever you're brewing or multiply it by whatever you're brewing, gives you about 10 million cells per mil. And that used to be a real standard. Now a lot of people want 15 million cells per mil or 1 million cells per mil per degree Plato. So, a 16 Plato beer, 16 million cells per mil. So there's the people who are kind of talk millions of cells per mil. There's the people who talk millions of cells per mil per degree Plato. There's the people who talk, just tell me how much yeast to use, which is okay too.
All right, we'll move on to the next question. Thank you for that one, Chris. Next most popular question also comes from Terrence. So Terrence says, not repitching related, but I've heard conflicting information on the optimal temperature for diacetyl rest for ales versus lager yeast. What's your recommended best practices for both Cerevisiae and Pasteuranus?
So mostly, and very few exceptions, your diacetyl, the higher your temperature diacetyl rest, the faster, the easier your yeast will be able to reduce the diacetyl, because it's a metabolic event. Yeast is not just touching, diacetyl and it's gone. Zap, right? They've got to bring it inside the cell. So other metabolisms that has to be happening. They have to want to get this NAD cofactor that they can get from breaking down diacetyl. So ideally, you still have some carbohydrates left. Fermentation happening. If fermentation's happening, and yeast are there, if you're fermenting colder, if you let it warm up while you still have a few degrees of Plato left in your attenuation, not left in the beer, that might be too low, right? Then as you warm it up, the CO2, the sulfur will come out a little bit. CO2 will come out a little bit too, which is nice. If you're brewing a lager, that sulfur, that's part of that scrub. And, so you can bring it all the way up to 68 degrees Fahrenheit if it's a lager, or mid 60s. But the higher, the better. For an ale, generally, we didn't talk about diacetyl rest of Saccharomyces cerevisiae because it was already at 68. But so many people now are fermenting below 68. They're fermenting 65 is the most common number we find. If I'm at a brewery, I go look at where their fermenters are at, they're at 65, even though they'll tell me, oh, that's 70. No, it's 65. It really is a big difference. And so you want to make sure you're doing the diacetyl rest. And even more importantly, with ales today, Saccharomyces cerevisiae, is the dry hopping and the hop creep. Hop creep is just metabolism, right? Because hops have carbohydrates on them. They're alive. I mean, they were alive. They're a plant. They have enzymes. They have nutrients. And so yeast are going to have a small little fermentation, sort of. That's a whole nother topic, right? That's also related to yeast health. Healthier yeast, less hop creep. And faster hop creep. So anyway, that's, since it had another metabolic event in the dry hopping, you have more diacetyl precursor made. So people are getting diacetyl from dry hop beers because their yeast are doing something again, making a little precursor. Now the yeast is being removed, and then you get diacetyl. So it's so unfortunate because it's so avoidable, but people have to dump beers all the time because of diacetyl. And so what are you supposed to do? Wait forever, right? And that's the challenge. Yeast health, higher yeast health, lower amounts of diacetyl because faster pickup of diacetyl. So comes back to yeast health again. But higher temperatures, the better. The only reason the Czech brewers and some of the British brewers used to use colder temperatures, Jamil and I were talking about that at Homebrew College. Jamil Zanishev, who co-wrote the book with me, and he really, I think he made a good point. He thinks it's that these yeast are top cropping yeasts. Even like our Czech Pilsner, it has more cerevisic DNA in it. It has more ale-like typings, but it's still lager yeast, even if certain DNA parts tell you ale, right? But anyway, since these yeasts are more at the top, if you cold diacetyl rest, now you're dropping the yeast through the beer. And yeast contact is also what you need to have diacetyl rest out. Diacetyl pickup.
Yeah, I would love to dive into that one deeper, but we've got 15 other questions.
All right, I'll try to answer faster.
Good question, Terrence. Our next most popular question is from Jacob. Jacob asks, life got in the way of a brew day. What to do with harvested yeast? Would feeding fresh wort prolong safe storage time? Any more practical suggestions?
So that's a different question that I'm seeing here. Can you read that one to me again?
Okay. So life got in the way of a brew day. What do you do with the harvested yeast? Would feeding fresh wort prolong safe storage time? Are there any other practical suggestions?
People have done that all the time. Feed fresh wort. Nothing necessarily wrong with it, except it's another handling practice that can more often, than not contaminate the yeast. Because now you're how are you going to feed a small amount to it? You're going to pour something in there? Do you have an aseptic way of transferring it? It gets a little complicated, but if it's done cleanly to where you can get cold wort into your yeast graduated cylinder or whatever it's in, then yeah, that's okay. If that's going to be before you use it. If you're going to put it back in the fridge, you haven't really accomplished anything except exciting the yeast again and putting it in the fridge. So life's going to get in the way. It happens on the commercial side too. You're better off still just trying to wait for that yeast to use it a little older than you wanted to. When I said yeast is 50% dead after 30 days, the reason why a lot of people still use it is there's still 50% alive. And you got a whole bunch of it usually. So doesn't mean the other 50% are in great condition, but it's not something you have to throw away either. That's where you can feed it at that time before you use it, kind of like a starter. I mean, people make starters. It's just that usually, they're adding the yeast to something that they've already made the wort in, which you could do, but adding cold wort on top of yeast is a little different than adding yeast on top of already clean and cold wort.
All right. Good question, Jacob, because we certainly all run into that. Peter Simons from Down Under. Peter asked the question, for homebrewers, does it really matter if you harvested top ale yeast from the bottom after it has fermented out?
Hi, Peter. And I think just collecting yeast from the top, if you can, is fabulous because that's what they're up there early. They're on top of the beer for the first few days. You don't have to wait till the end. And you get the freshest, highest viability yeast you can. Open fermentations, yeast love it. Ever do one? If you do, you'll notice, hey, gosh, the fermentation is faster. Yeah, because yeast like it. I mean, who wants to be in a closed container as a living organism, right? So, and again, they're not anaerobic, so they don't really like that CO2. So yeast like it. The yeast health will be better. But again, not many people have open fermenters. Not many people want to collect from the top. So there's nothing wrong with collecting ale yeast from the bottom. In fact, that's what most people do today. You just, you just have to realize that it has an impact on its health, its longevity, but it's all the practices we have today about collecting yeast really come from bottom collecting. But unfortunately, ale yeast are pretty robust.
All right. Our next question is Russell Gibbons has the most popular question. Down in Mexico. Hey, Russell. And it switched around, but let's get it back to Russell. Storing harvested yeast by freezing it. Is that really possible? And if so, what's the easiest way to do it?
Freezing yeast is what labs do. We store yeast at minus 80 degrees Celsius with about 50% glycerol. And that is how you store them forever. That's not usually, it's sort of unheard of to do in yeast crops because no one has a minus 80 freezer usually for holding yeast slurries. So I've never seen that in commercial practice. But if you store them in your normal freezer at home, there's a lot of it's just not cold enough, and there's ice that can form too slowly at that temperature, even with the glycerol. So it's not bad. Like you lose about 10% of yeast every freeze thaw. So if you wanted to freeze yeast and you said, gosh, I'm going to not be able to use this for 2 months, and you freeze it, you're likely to, on that first freeze event, if you thawed it right away, it'd be about 90% viable if you were at 100%. And depending on how long it stayed there, you'll lose some more yeast because of the freeze thawing that happens in frost-free freezers. That's why they don't build up frost anymore. But, it'd probably be about 80%. So then you got to say, okay, was that 80% better than, 2 months later, it's probably 35%. So there are times like that it could make sense. But, we don't see it in general practice. And like in our packaging, we say do not freeze. Again, it's not going to kill it all, but you don't need a ding on the viability if you don't have to. But we've had whole shipments, to homebrew stores, the whole homebrew store freezers, refrigerators. Some people use the chest freezers modified with a thermostat to keep it at refrigerator temperatures, just like a lot of us have in brewing. I used to hold all my carboys in a top-loading freezer like that, set at fermentation temperatures. Sometimes they fail and it freezes, and whole loads of homebrew yeast have failed or frozen, and it's not enough to have had any kind of, they haven't had to replace the yeast and things like that. So it hasn't happened that often, but what I'm saying is even when it's happened, the yeast has worked fairly the same according to those incidents when it's happened. And of course, we measure viability. That's why I know they lose 10%.
So what if your fridge doesn't go to that minus 80 C? That's pretty cold for a typical home freezer.
That's what I'm saying. None of them do. So that's why it's not done. I'm saying your normal home freezer, minus 20, higher, depending. So, you're not, that's not what you want to use for freezing yeast. But if you do want to, like I'm saying, you're going to lose some viability, but you don't lose 10% at minus 80. I'm talking about, your normal freezer at home.
All right. That was a good question, Russell. Terrence has the next most popular question, and we're almost at the bottom of the hour. And Chris, as I told you, and the audience knows, I have a hard stop. So we've got, a dozen questions, and so we're going to have to move these along. So what are the benefits or drawbacks from top cropping yeast for reuse versus collecting after cold or soft crashing?
Top cropping is always better. Lager yeast, ale yeast, whatever it is, it's always better, except the risk of contamination is higher. People have gone to bottom collecting yeast not so much for the risk of contamination, which is a thing and an issue, but it's mostly because those commercial fermenters are easier to clean when they're closed and conical, because you put a spray ball on the top and no one has to get inside and scrub it. So it went to that for that reason. It didn't go we didn't start bottom collecting because it was better for the yeast. We didn't start bottom collecting because it was cleaner for the yeast. We went bottom collecting because it was easier to clean the tanks with a spray ball. So do you have to copy that in home brewing? No. You can collect from the top. You can collect from the bottom. Even German lager beers, right? You collected from the top, but you moved that beer within a few days to a closed tank. So, and that's where it would continue out. And again, lager yeast didn't stay on top very long, so it wouldn't be in their open fermenters for very long. So if you can mitigate the effect of picking up room microbes by having very clean practices, then you're always getting better yeast by top collecting.
Is that practical to mitigate? For a home brewer, I mean, most of us don't have clean rooms. So,
well, open fermentation doesn't mean not a top on it. I mean, you've seen, you were talking about Sierra Nevada at Mills River. Their open fermenters have tops on them.
Well, some of them do. They have an open fermenter room, but it's a sealed room. Well, I say sealed. It is glassed, and there's no windows, and I think it has a very specific airflow. So
exactly, they made it right, and they keep them open, kind of for the show. You put the top on for the CIP, so you've got it open fermenter that you can still CIP. And that's kind of like, gosh, why didn't anybody else think of that? And probably had, but they've discovered it too. I mean, or found who had. But say some of the earliest fermenters, the plastic buckets with a lid on it, the yeast is still on top. Take the lid off. Take off the yeast.
All right. Our next question, looks like we've got 10 left. Terrence, that was a great question. Terrence has the next question. Terrence has a bunch of good questions. Any tips on helping yeast retain glycogen reserves for the next repitch?
Again, just kind of maximizing the yeast health. Glycogen is built up in the kind of starvation time. That's not high Krausen. I know people write that a lot, but high Krausen is not starvation. High Krausen is not high glycogen levels. And people talk about that with starters, like, do a 1-day starter instead of a 2-day, because the 1 day is at high Krausen. Yeah, and it hasn't started building up glycogen yet, right? But it's a fine line between waiting another day and then how much glycogen would still be stored. And so I believe in a little patience with yeast. I believe in building up the glycogen and building a nice plump cell that's going to have a lot of survivability. So you got to starve a yeast a little bit to make them survive better later on. Not overdo that. That's the tricky part, because then you're going to get them to consume what they just stored. So generally that's 2 days in most yeast setups, if you're on the starter side, propagation side. Just in terms of collecting yeast, that's why if you collected that first day after terminal gravity, you've got your terminal gravity, means sugar wasn't present around the yeast. They have started to flocculate, which usually takes starvation to flocculate as well for most strains, to express flocculation characteristics on their cell surface. Now they're building up the glycogen. Now they're dropping down. And you want to collect them at that height of their glycogen and keep them cold. If you give them oxygen, glycogen's gone. If you don't keep them cold, glycogen's gone. So keeping them cold, keeping oxygen away, keeping the highest health going into that setup, having the right zinc, having the right fermentation times are also going to help you have a cell that's going to hold that glycogen well. along with maintaining temperature and no oxygen.
Well, that was a more complex answer than I expected. Our next question comes from Terrence. Also, are there any key developments in yeast science since the yeast book was produced back in 2010?
Well, there's a lot more. Yeah, I mean, Drill and I talk about it all the time. That gosh, it'd be great to write another book. And we toyed around with it, but beyond just our interest in writing the book, there's a lot of new stuff. There's new beer styles. Here's another example. When I made that game on brewing, Brewmaster game, a little card game, sold a bunch of them back in the early 2000s. But it was just fun to hold hops, malt, and yeast cards, make different beer styles, and have some things happen all over board. We didn't have IPAs as one of the styles. People can't imagine probably craft beer without IPAs. But that was the case. So time just keeps changing. It was pale ales and ambers back then. And things have changed in the last 10 years. We didn't even talk much about sour beers, even though they're not new. It just wasn't really being actively done by a lot of craft brewers. So sour beers have kind of come and gone. They're not gone, but you know what I mean? The popularity got really popular for a while, meaning every craft brewery in America wanted to have sour beer. So it wasn't just a place starting a sour beer brewery or a home brewer saying, I make sour beers. We all were making some sour beers. And then it became hazies and juicy hazies and Kvike. So there's different beer styles now, different strains of yeast. There's interest in lower carb beers again, lower calorie. There's the full genome sequencing. There's GMO. There's non-GMO ways. There's way more higher advances in dry yeast. In fact, we released 2 strains this year in dry form, California Ale yeast and London Fog, after about a decade working on them. So, I've got a pretty big list of new things or things that have happened and will continue to happen. But that's a little bit of it.
Yeah, I'm a little surprised that there hasn't been some thiol questions. That's another can of worms.
Yep. Yeah.
Terrence asks the next question. Are there any studies on the conditions that cause cell mutation after a number of generations?
Well, yeah, most of the yeast work happens outside of brewing, right? But sometimes brewers and other yeast scientists get together. A lot of scientists like beer too, right? So I've got to do some different collaborations together and different projects, including like the DNA sequencing project, and there were other teams working on it too. So I got to know some of them, and there's the stuff with the Saccharomyces eubiotis, creating the Saccharomyces pastorionis work. And so in those industries, they look at our mutation levels and go, why are brewers concerned? I mean, these strains are so stable. We talk about repitching 5 or 10 times, and if you do the math according to what most yeast microbiologists think, you're really not going to see many mutations for 100 generations. Well, we are concerned so much about flavor for valid reasons, right? Fermentation, flocculation. We've got a lot of genes controlling flocculation and other properties in terms of flavors and beers. And so if those change, then our beers can change. So when we're looking at flocculation, mutations, we're really concerned about a very small number of mutations. So respiratory deficient mutants is one way you can do a plating and look for cells that won't grow. And then it gives you an idea of mutation rate, but it's not really done that much anymore. I mean, we offer it as a test too, and sometimes people ask us to test their yeast culture for a percentage of respiratory deficient mutants, but that's still not really telling you if another mutation is there. One day we'll all be able to do full genome sequencing, next generation sequencing right in our own facilities. Just how's my genome changed? Just like 23andMe is doing for you, full genome sequencing of your cells for understanding things about your family history and your genetic makeup for potential for diseases and stuff like that. That's still very specialized, right? But someday, hopefully, that'll just be something we can all do and know what's in our food, know what's in our beer, But I guess that's probably far away, so fairly far in the future.
So you're saying brewer's yeast is unusually robust and that it does not mutate like other cells?
Well, it's mutated rapidly under the hands of brewers to make the beers that we make. It doesn't live in the wild it very well because the things that we forced on it. It doesn't make phenols, normal brewer strains, which also makes it not really able to live in the wild on plants and stuff. So you look at mutations from that viewpoint, and there's a highly directed mutations that took yeast from where it was in the wild to us being able to use it as brewers. But now in our breweries, the number of mutations that can build up into the conditions we're giving them would theoretically be about 100 generations. But practically, you can see mutations in a few generations, 1 or 10 or 5. That's, say, changing flocculation. And so for those reasons, brewers are just more concerned and careful about using their yeast too many generations. So you
so the yeast
for best practice
live in a more benign environment, and so they're less prone to the mutations that they would if they were in the wild.
Yeah, and they're not mating, so yeah.
This is an electrical engineer talking to a microbiologist.
Yeah, that's the beauty of brewing, right? We come from all different backgrounds, and we can communicate through what it means to beer.
That was a great question, Terrence. Next question comes from Adam. What are the pros and cons of these two different approaches? Overbuild a yeast starter and keep a portion for the next starter, or number 2, harvest yeast from a fermented beer to use in the next beer. So overbuilt yeast starter or harvesting yeast from a fermenting beer.
The hard part about creating a best practice answer for something like that is, and for the user asking the question, is they both seem like they work, right? So many things you do in brewing will work. It's what the best practice that's been handed down. Usually it's because it hadn't been handed down because best practices gave somebody a better degree of success. But starters weren't a thing in the history of our brewing, So it really came out from companies making liquid yeast and homebrewers needing to grow it up. So they are both okay. I mean, leaving some of your yeast that you grew, it's going to die off a little faster, maybe because you were giving it more oxygen, but it also didn't have as much of a longer fermentation. There's a lot of reasons that's still why the yeast viability goes down so much after you collect it from a beer. It came from the bottom of the beer for one reason. Top crop yeast don't do that as much or have this big of a viability drop. So long answer is sort of like both practices will work. What is that best practice? I would say collecting the yeast from the beer. Afterwards, it's gone through its growth phase. It's now a couple weeks down the line. Your other overbuilt starter is now still in the fridge. So I would collect it from the beer.
I was guessing that was the right answer. Makes me feel good. I was guessing it was mostly because of the oxygen, because generally you put it on a stir plate and those things are stirred up like crazy.
Yeah.
Well, speaking of stir plates, I know I saw a question, and this should be easy for you. Having a stirrer, one of the magnetic stirrers in your Erlenmeyer flask, and you put it in there and you make this great starter. Are you not potentially damaging yeast cells with that stirrer just beating them all to a pulp?
You are. That's why it's not really done commercially. There's mixing and there's aeration, but stir plates are a very lab scale thing that homebrewers have grabbed onto, and it's easy to do, but it's not done, again, like large scale commercial applications.
So it's like putting your yeast in a blender?
Not as bad as that. Not as bad as that. But they're shearing. Yeah, cell surface shearing, which affects
Okay.
flocculation, which would affect final yeast culture. But if it's an early part of a lab propagation, that's where it's done. Later on, it's more about aeration or stirring slowly, kind of keeping things in solution, but not using a stir plate to generate, bubbles. But it's really interesting that I caught on in homebrewing, and it's because people showed people how to do it, and it's easy and it's pretty effective.
All right. Well, I kind of skipped ahead of a question. So Terrence has another question. If you add zinc nutrients to your yeast starter, do you still need to add nutrients to the wort at pitch?
Yes, because they still have to grow in the pitch. So everything, it's an interesting thing. And a similar thing has come up with Cerevomyces in the past, because we've had Cerevomyces, for about 20 years, made first by Lomond, and now you can get it from other suppliers too. But the homebrew version is just us. And it is yeast that has been grown up in this presence of very high zinc, and then the yeast is killed, and the zinc stayed in the yeast membrane. And so people would use that to supply zinc, because it doesn't, the cells that it's captured in doesn't go as part of the true. And that's what happens when you add mineral zinc into your kettle or whirlpool. It's just gone. Don't even add it. The only reason people aren't using more of it is it's just more expensive than mineral zinc, because it's a yeast culture. So what people have been talking about, and I've been sharing it too, because I think there's really good ideas, is cold zinc addition. That's you adding it when you add it to your beer. But if you brew the yeast up it with zinc in your starter, it doubles, it grows as much as it might grow, and it uses that zinc. Now you put it in your beer, it's got to grow again. No matter how much yeast you use, it's got to grow. So people would ask us that, say, with Cerevomyces too, like, okay, I've used in the first generation, do I have to use it in the next generation? Yes, because it's going to grow again. And as it's growing, it needs that zinc. So you would need it, yeah.
All right. We're down to, looks like 6 questions now, and a little less than 15 minutes. Is there a definite limit on repitching several generations of the same yeast, assuming the beer is under a particular ABV? Does this differ from strain to strain?
I was reading some of your it's really fascinating thing going on here. I'm not used to the Crowdcast, but it's really, you can kind of get some input from all the listeners. So that question about same ABV, what was the point? Sorry, Doug.
I'm sorry, I'll come back to it.
Yeah. Read at the same time.
Is there a definite limit on repitching several generations of the same yeast? And this assumes the beer is made under a particular ABV. And does this differ from strain to strain? So I guess he's saying, I guess if it's a lower ABV, maybe, is what Terrence mentions, or maybe Terrence can put it there in the comments.
I mean, you can collect the same yeast from different beers. I mean, that's what most people do anyway. If you want more consistency, the same beer is great. But if you're going to be making the same beer, gravity is not as important as color. I mean, the lighter colored beers, the yeast health is higher for unknown reasons, perhaps nutrient levels. But if you have your choices, like people used to say, oh, IPAs, never collect yeast from IPAs. That just got said, but it wasn't actually necessary, because the thinking of the hops, which has gotten all different in different forms of IPAs now. But, and also the ABV, 70 IBUs, 7% IPAs in the 2000s. But West Coast IPAs were pretty light. So Mitch Steele, when he was working at Stone, said, they had to start collecting yeast from the IPAs. They had too much IPAs going, and that was where all their yeast was, and it was great. It thrived in the next beers. So again, it's you sort of get these comments of everything time something's new, like I can't use the yeast from here, or this won't work or that won't work, and then people do it and figure it out, and a lot of times it's just like it wasn't really that complex. But craft brewers are blazing so much ground, reinvigorating old styles, sometimes creating new styles, sometimes just making them alive again. And there's no textbooks, no information, and they've had to figure a lot of things out themselves. And that's one of the great things about this the whole craft beer movement.
So you shouldn't, or you should maybe be careful trying to harvest the yeast from your Russian Imperial Stout.
Yeah, right. Dark, high gravity, sweet. Not the best. No, that one I would not recommend.
So
but
you know
what?
Not...
Still work. That's the challenge of carving out the best practices versus, gosh, that worked. I guess that was okay. Well, how could it be better?
Well, that's that, and you said there's no good studies yet that really make it clear as to why those dark malts seem to compromise the yeast.
Yeah.
All right. We're down to 5 questions, I think. George has the next question. Can dead cells in a slurry be considered a nutrient?
No. The problem is it's a bit of it's a good question, because I think it's a bit of a misconception that it happens. So the problem is a yeast cell to another yeast cell, they can't eat it, right? So there's no real nutrient provided there unless the cell blew up a little bit. But even if the cell blows up a little bit, the yeast cell can't eat protein. We can, right? We digest it all. I mean, it's not going to do anything with it. So what happens to a yeast cell to make it a nutrient is it's got to be to make yeast extract. Extract the protein out of the yeast. That's what a real yeast-based yeast nutrient is. And that doesn't come easy. You could take some of your yeast. Every home brewer could do it. Take your yeast and put it in a 60°C water bath for 48 hours on your stovetop. Your house is going to smell really, really bad. It's fun though. You should, make your own Vegemite. You can make your own yeast extract and do all different things. So you hold it at 60°C for 2 days. What happens is the yeast cell itself turns on enzymes to break down the cell wall. That's step 1. And then the proteases break down the proteins to all the little amino acids. So commercially, what would happen is that would be dried down now. You feed that to yeast, and here's a whole bunch of amino acids the yeast can consume and then make proteins out of them. But you can also, there's other ways to break down cells with enzymes and stuff, but self-autolyzing them is something you could do at home. And then you could use it as a nutrient source to your yeast.
So you've got to turn them into fertilizer first.
Yeah, right. And you could also, amino acids like that, yeast extract is used to flavor foods. It's used to make things taste like meat. For those that don't eat meat, it's a big additive for meaty, beefy characteristics.
Great question. Wow. Thank you, George. Jacob has the next question. As we're beginning to wrap this up, we're down to 4 questions. Best practices for propagating lager yeast from a slant for cold ferment and cold maturations. Cold prop, warm prop, cold is the last step. So what's the best practices for propagating lager yeast from a slant?
Propagating lager yeast from slant. We know that lager yeast like colder temperatures. They don't grow at 30°C where ale yeast can. So over 90 degrees, right? Fahrenheit. So lager yeast, because their temperature, they can ferment lower, which is cool. They have the DNA to ferment cold temperatures. They still prefer warm, but not as warm as most yeast and bacteria. So that's one of the really defining one of the defining characteristics of lager yeast, that they can't live at high temperatures. So most people would like to propagate yeast warmer than your beer fermentations to generate more cells. With lager yeast, you just go a little bit cooler. I mean, if you grew your yeast at 75, even to 80, you can grow ale yeast and lager yeast at that temperatures. What is more common in propagating yeast is your last stage before using. This was very big at Coors and other big breweries, where you would lower, you'd start at laboratory temperatures, say between 70 and 80 Fahrenheit. You go that way through the initial stages of propagation, and then your last step before seeding the fermenter from whatever last propagator, you would try to get it to the temperature that you have your last stage at the temperature of your fermenter. A common practice that was best practices at the time, that probably has a reason that it was best practices, because if you do it time and time again and you looked at the temperature changes, especially in a lager, which has more shocking temperature changes, that changes the protein expression of yeast cells. Could it have once in a while an effect on a beer flavor or fermentation? Most likely. Would you notice it once in a while? Maybe not, because it wouldn't be something that would happen every time, a temperature shock. So that's why best practices around temperature tended to be something that people didn't really believe in because they never saw it happen. But it would be preventing something from happening occasionally.
Yeast can be pretty forgiving, is what I'm picking up from all of this.
Because they're living, because we should be very, I'm trying to, describe it in the ways of them being living and us putting some narrow parameters on them to make the best beer possible. But in life, their parameters are way out here. So yeah, we can do all of these things we want with them. We're trying to treat them just like this, so we get the most consistent performance from them. But outside of this doesn't mean they're dead or don't work.
Wow. I'm glad I didn't go into microbiology. David has a little bit of a long question here, and Chris, we're down to about 7 minutes.
Okay.
I have a question for you. Your new packages of yeast are really nice looking. Unfortunately, your new packs of yeast are really expensive for home brewers. What can you do to save us some money? By the way, I have recently turned in a 150 old vials that I was saving and receiving some nice rewards. Thanks for that, David Cords.
Thanks. Yeah, we still have that going alive. It's called Fermentation Society now. It's a customer club, so you can return the new ones too and get some free stuff. So that's one way we try to make it a little easier for you. Yeah, everything's a lot more expensive than it used to be. And we talk about that every day here because we're aware of that too. I mean, our staff wants to be paid more. Things cost more. I remember the first time going to Australia on a beer thing to visit some of the home brewers there, and I saw I had a cheeseburger and it was $15. And I almost lost my mind. It doesn't sound funny anymore, but at the time, the food prices were so much higher in Australia. I just never seen that in the U.S. When things were, a cheeseburger was still it was a joke to say a $5 cheeseburger or even a $5 beer. That'd be a joke back then. But now our prices are that way. Now there's $15, $20 cheeseburgers. There's $15 yeast. There's malt and hops that are higher. So, that's stuff that's way out of our control. I can tell you yeast is more expensive to make than ever. So try to give a lot of value for what it costs. And we've gone to the direction of more yeast in the package and that type of package because of listening to home brewers. I know not everybody agrees, like you're saying. Some people say, I don't care what it costs. Give me this much yeast. But then, of course, there will be people that say, "Gosh, I like the smaller one that costs less." And I'm aware of that, and I'd like to be able to meet everybody's needs, but we sort of can only have one homebrew size. When I entered business for White Labs in 1995, we came out with a larger package than had been out there before too. So it's not surprising that other people came with bigger ones. And just, so we're really trying to now kind of maximize the amount, or really talk about the amount of yeast you need for a particular beer. That's why we built a calculator behind it. So on yeastmed.com, we have a calculator that has a slider. That's the unique part of the slider. You can slide to whatever pitching rate you want, millions of cells per mil or millions of cells per mil per degree Plato. And since we know the cell count in those packages, it tells you how much yeast to use. So perhaps you could also use that calculator to see how much less yeast you could use. It has a cap. You don't need to use the whole package in one sitting. You could use half of it. You could use a quarter of it. You could make a starter with it and then use the rest in a beer. And the slider will help show you still what kind of cell count you have in the beer. And you can cap it and have the same viability up to the shelf life. Done a lot of those tests. You think adding the oxygen at that point could, the initial thoughts were it would lower the viability in storage, but it hasn't.
So you're saying I like to brew small batches, like 2.5 gallon batches. So could I get one of your new packages and pull out enough cells for 2.5 gallons and still keep that packed for a while? Yep.
Yeah, you can. And I mean, I'd like people to do that with it because there's a lot of technology in that cap. It wasn't, it doesn't have to just be, because it's to get that on the pure pitch packages, to make the next generation, to have it sealed, to have all the things that we needed. It's a lot of work went into that cap. So it wasn't just to make it more convenient in my ways. It was also to give people more ways to use the yeast, to make starters, to make little bits, to add other pieces, to use 1.5 if you want to add to the modularity and flexibility of how people can use the yeast.
I like that, because I know the dry yeast package, if you open those, while you can keep them, they don't keep real long. Mm-hmm. All right. Well, I don't want to keep asking questions. We're down to about 2 minutes, and looks like we have 2 questions. So we're going to have to rapid fire through these, and so I won't have an unceremonious end. Jim asked, can you recommend a microscope for cell counts for homebrewers?
You want a microscope that you have about 400 power, a full magnification, usually a 40x objective. And you don't need 100x, 1,000 power, because yeast look great at 400. And that's those microscopes, when I started, that was before anything was really made in China. Everything was really expensive but really good. But now there's so many inexpensive. I mean, we used to sell microscopes. I don't even know I don't think we even do anymore because they're so cheap to be able to buy, and a lot of them are made in China and other places manufacturing. I don't know how manufacturing got so much less expensive some places, but our food and everything, because it stays in our countries, it's got really expensive. Anyway, hold on the topic. So yeah, it's really easy to buy an inexpensive microscope, 400 objective. That's all you really need. You want a stage that moves around a little bit so you could, move your and you want to get a hemocytometer so you can count the cells in a defined square so you know how many cells you have. So an inexpensive microscope and a hemocytometer.
All right, and we are down to about 40 seconds, Chris. Okay. First of all, I wanted to tell you how much I appreciate your time, both at HomebrewCon and doing this event. I don't know if you can join us or not in the after party, but we're going to jump in a Zoom call for just a few minutes. If you have time to jump in, we would really appreciate it. If you don't, I understand.
Okay, yeah, I'll jump in for a minute. I got to go cook my sausages soon. But,
I understand. All right, for everybody that joined us, we have just seconds left. I'll see you in the after party. But again, Chris, thank you so much. I appreciate it.
I enjoy it. It's what I do for my life, and I love talking about it. So thank you.